To wrap up this chapter on solutions, we're going to discuss a type or a collective of mixtures that are somewhat like solutions, although not quite. We're going to see that these mixtures can be called colloids, and we'll have a later one called suspensions as well. These are not quite true solutions in which there are completely dissolved solutes, but rather we have large particles that are kind of floating in what's called a dispersal medium. So instead of a solute and solvent as vocabulary terms, we have a kind of solute-like particle that is dispersed, the dispersed particle, and then we have the solvent-like dispersing medium. So if we want to continue this analogy, we're actually going to be calling it the dispersal medium and the dispersed substance would be better terms, because we don't really have true solution behavior. These are kind of not quite solutions and not quite heterogeneous mixtures either. And we have plenty of examples of these. For example, milk. Milk is a colloid. It is a not quite solution, but something a little bit different, where we have fat particles and proteins dispersed throughout water. So in this case, we're going to have our dispersal medium be water, and then the dispersed substances, particles, would be fats and proteins. You know that milk, we see is, whole milk, 2% milk, 1% milk, non-fat. That's all the amount of fat within the milk. And you'll see on the milk, it'll say homogenized on the label. And that's because we're not expecting it to be like oil in water, where we have the oil just floating on top and then we have the water below. But in fact, these are emulsified together. And as a result, we end up with a colloid. Another one would be something like smoke. We can stick to our original color here, where our medium, the thing that is kind of the solvent, that's acting as the solvent, is going to be air, and the substances would be things like soot or dirt, small particles, solid particles. Whereas with the water and fat for milk, for the emulsion there, they're both liquids. And that's fine. You can have colloids that are liquids dispersed in liquids. You can have, in this case of smoke, or we have solid particles dispersed in a gaseous medium. Something like a cloud would be liquid particles dispersed through a gaseous medium. We have liquid water that's dispersed in the air. Styrofoam would be another example. Shaving cream, whipped cream. These are all aerosols, things that have air or gas dispersed in a liquid medium. So there's all sorts of various types you can have. And what's interesting about these is that they have properties that are not quite solution properties, but they're also not quite pure substance properties either. So we're going to see that as a result, there's going to be a lot of interesting applications that these can have. Or they're just cool, like clouds and smoke. Cool stuff, right? They have kind of intermediate properties, where they're not quite solutions, and they're also not quite heterogeneous mixtures. And there are plenty of examples of these that we can go over. Like blood, well, it's more of a suspension, but your blood plasma would be a colloid. And what's interesting about these is that the particles within a colloid are usually about 5 nanometers to 1 micrometer, or 1,000 nanometers in size. And so they're actually big enough that they will scatter light, but not so big that they will fall out of solution due to gravity. Something like sand, which has particles of millimeter size, those will fall out of solution. And so if you take muddy water and allow it to sit, you'll see that those particles will settle out because they're big enough. But what's interesting is they're also able to scatter light. And so if we take a look, there's a property called the Tyndall effect, where if we shoot a laser beam, which is a concentrated light source, through a solution, we don't really see it. Can't see the laser. But through a colloid on the right here, we see the path of the light very clearly. And in fact, we can see that light being scattered as it travels through the colloid. And then as it exits the colloid into the air again, which is a solution, we no longer see the laser. And this is the reason for that age-old question of why is the sky blue? It's because of colloids. In the air, there is smoke particles, soot particles, there's dirt particles, there's all sorts of random little debris floating in the air. And as the sun's light goes and hits these particles, the blue light waves are deflected more because they're smaller, so they're easier to deflect, and a shorter wavelength, right? And so as a result, it appears blue to us. And as the sun moves more and more towards the horizon at either sunset or sunrise, we end up passing through so much of the atmosphere, through so many scattering events, that we start to actually not be able to see the blue anymore as it's completely dispersed. And as a result, we start scattering the other light waves, the oranges, the yellows, the reds, as we pass through more of the atmosphere. And so now you can finally answer that question, right? It's all because of colloids. And we're going to end here with just one more little part here, which is one more type of not quite solution thing called a suspension. And this is technically more of a heterogeneous mixture. One day I'll be able to spell that word right on the first try. Or rather, I'll get it right, Okay, so this is a heterogeneous mixture. Think muddy water. So if you go down to the river, okay, there's no rivers in Midwest, but take some dirt, put some water with it, mix it around, you'll end up with kind of brown water, right? But if you let that sit, it will separate. It'll separate into dirt and water again. There may be some things dissolved in the water now. There may be some colloid type particles within the water now. But the difference is here, the particles are big enough, they're bigger than 1,000 nanometers in diameter, assuming roughly spherical particles, and it'll separate over time. And so the behavior is not quite that of a colloid either, because now these are even bigger particles. Typically, we can't see through suspensions very easily, unless they are very dilute. But the difference here is that the particles are large enough that they will separate out over time. True colloids will not separate. So something like a cloud, sits around forever until it's either completely dispersed or it nucleates and forms rain. Or again, smoke can disperse as well. So those aren't quite suspensions. Blood would be another great example of a suspension. We have our blood cells, red blood cells and white blood cells and all that, platelets, all suspended in blood plasma. If you let blood sit, over time, the blood cells will separate out again. You can see that they also can do it more quickly through a centrifuge. And perhaps if you, took introchem with me, we did some double displacement type reactions where we saw precipitates forming. Those are suspensions as well. If we gave them time, they would separate out. But the most important suspension of all, blood notwithstanding, is coffee. In the immortal words of Captain Catherine Janeway from Star Trek Voyager, to coffee, the finest organic suspension ever devised. And with that, we're done with solutions. And next week, we'll move on to talking about chemical kinetics.